All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap. Very excited about this one. It's got a demo. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for Ara, please don't hesitate. Just go ahead and use your question and answer interface, and we will try to get to as many as we can during the question and answer period. We also have a very interactive chat interface, so we encourage you to please chat us your questions, comments, suggestions, whatever you want to send over to us. We will be more than happy to address it. And then finally, at the end of today's webinar, we are going to be doing a drawing for 4 $100 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Embracing Change, Policy as Code for OpenShift with OPA and Gatekeeper. Our speaker today is Ara Polito, who is the technical evangelist at Datadog. Ara, so great to see you again. Thanks so much for joining me today.
Hello, thanks for having me. So today we are going to be talking about embracing change, policy as code in OpenShift with OPA and Gatekeeper. OpenShift goes with a capital S. I was reminded just now, so sorry about that. OpenShift with a capital S. So my name is Ara Polito. As I said, I'm a technical evangelist at Datadog. I've been working on Kubernetes projects for the past 5 years. I was actually part of the team that created the curriculum for the CKAD. So if you have any questions about that exam, you want to take it, please reach out as well. I can give you tips or comments. And that's my email and my Twitter handler. So feel free to reach out for any of these 2 methods if you want to. So today we are going to be talking about OpenShift, but first, what is Kubernetes? So basically, Kubernetes is a container orchestration platform to help you run your containerized applications in production. And it's completely open source. It's owned by the CNCF Foundation. And it has things like auto-healing, auto-scaling, a lot of great features to run your containers in production. OpenShift, again, missing the capital S, it's a Kubernetes platform that enables enterprises to run containerized applications in production in a fast, reliable, and secure way. So it's a full platform built on top of Kubernetes. So you have the same thing that you have on Kubernetes with more services to help you even more. I work for a company called Datadog. So this talk is not about Datadog itself, but we will show a couple of screenshots while we are talking about Gatekeeper as well. Datadog is a monitoring and analytics platform that helps companies improve observability of their infrastructure and applications. We love observability. We think that it helps ops and devs equally, that it helps breaking silos in the companies. And obviously, we also include that infrastructure and applications includes Kubernetes, OpenShift, and also the applications that you run on top. But today we are going to be talking about policy. And I know sometimes that things like policy and governance, all these things are not super exciting, but I'm going to try to make it exciting. And as I'm trying to make you as excited as I am with Gatekeeper, which is, I think, is a fantastic project. So what is policy when we are talking about software systems? So basically, when we are talking about software systems, policy are the rules that governs the behavior of a software service. So basically, what you can and cannot do with that software, what your users can and cannot do. And if we are talking about what your users can and cannot do with OpenShift, it feels like we already have that, don't we? We already have things called RBAC, which is role-based access control. And this is We already know, if you're using OpenShift already, you know what RBAC is. If you're using Kubernetes, you will know what RBAC is for Kubernetes. But just in case, basically, RBAC, what it gives you is rules with this format. You will have a subject, a Kubernetes API resource, and a verb. And all the rules will be, for example, the user ARA, so myself, for the type of resource pod, which is one of the type of resources that we have in a Kubernetes or OpenShift cluster. She can create, get, and watch those resources. So that is what RBAC rules look like. And they are fantastic. We all know them. We know how to organize them. So why do we need something else? And the reason why you need something else is because RBAC, basically, it's auth for Kubernetes. But policy, any policy that you can create, it's a lot more. Let's say auth is a subset of all the policies that you want to create for your software, in this case, for your OpenShift cluster. Things that you cannot do with RBAC. Can I run an image that it's coming from a third-party registry? Or has my pod all the labels that are required by my organization? These things you cannot describe with RBAC, because basically RBAC says, I can create pods, for example. And once I can create pods in a particular namespace, what it's inside the pod, the container that I'm running, the metadata about that pod, that it doesn't get controlled. It's like, you can create pods, do whatever you want. So we need something else. We need to be able to create these things. And you need to create these things for your OpenShift cluster. But probably if you're running the infrastructure of your company, OpenShift might not be the only infrastructure that you have. You may have things like service meshes and gateway APIs, and you may have resources in the cloud that you manage with things like Terraform, and you may have stateful applications like Kafka. So you may have a lot of different things, and probably you want to create rules for all these things. And it's a little bit difficult if I have to learn different languages to describe these rules over and over again. And this is what Open Policy Agent tries to solve. So basically, what it tries to do is to say, okay, instead of making it specific to every single piece of infrastructure, I'm going to create a language, and I'm going to create a framework that it's completely domain agnostic, and I'm going to decouple making a decision about a policy, about a rule, and enforcing that decision, which is the thing that it's specific to some infrastructure. How does it do that? So basically, the OPA framework, the only thing it has is it's basically a decision engine that it will take a set of policy that you have written in a specific domain language called Rego, that we are going to see a little bit today, some data in JSON, and then you get a query about something that, can I do this in JSON? And basically using that Rego policy that you have created, you have written, and data that you have stored as well, it combines all these things together and returns a decision, just a decision, not an enforcement, written in JSON as well. So pretty domain agnostic. So if OPA doesn't enforce policy, how do we enforce these decisions? Because obviously we just don't want to say, well, I'm not supposed to do this thing, but to avoid to do it altogether. So before that, we are going to talk a little bit about the OPA and Rego. So we are going to try to explain a little bit how Rego works. Again, one of the goals of this talk is to ensure you that you can get started Gatekeeper and OpenShift even without knowing Rego. But just so you know, just to have an idea, let's imagine that we have this code. This is Rego, and it's a complete declarative language. So it might be a little bit confusing at the beginning. But basically, in this thing, we are saying, let's imagine that we want to create rules for an API. And we say, OK, by default, we are going to deny everything. But if the input method is get and the user is Bob, we automatically say true, because let's say Bob is a super user. If it's not Bob, and the method is get, and the user and the path is equal, then we also allow that API request. Let's see some examples. Let's imagine that we have this API request, and it's the method guest, the path is finance, salary, Alice, and the user is Bob. Because these two things are already the first rule, we are going to pretend, okay, this is allowed. For this second rule, the method still is get, so we are fine here, but the user is Alice, okay? The user is Alice, so we are here, and she's trying to get John's salary. So input path second, so 0, 1, 2, John, these two things are not equal, so I'm going to return a no. This is not allowed. If Alice tries to find her own salary, then it's going to be approved because these two things are going to be equal. So again, just to give you a little bit of an idea of how Rego is declarative and not imperative language, how we are using JSON and input, and it's going to return JSON and output, but we are going to see all the ways. So going back to what we were saying, so we have a lot of infra with us. We have all these things that we want to create policy. So how we enforce those things. The way you do that is through plugins. And if you go to the OPA website, you will get a list. This is a screenshot. There's actually a lot more. For every piece of software that you can think of that it's open source, probably there is already a plugin, because Open Policy Agent is becoming the de facto way of creating these policy rules for cloud native projects. So there are a lot of them. And because it's JSON, it's fairly easy to create this plugin. So there are more and more being created all the time. So what is Gatekeeper? It's actually this. It's one of these enforcements for OPA, particular for Kubernetes environments. And that includes, of course, OpenShift. And the way it uses this is that Gatekeeper as a binary embeds OPA inside as a library. So OPA, you don't have to deploy OPA outside Gatekeeper. If you deploy Gatekeeper, it's going to include already the engine, which is important. So how does it work? So how do I enforce that policy? So in order to understand how does it work, I think it's important to recap what happens when we do an API request to the Kubernetes API server. It goes through three phases. First, it goes through authentication. So I'm authenticated in this cluster. If the answer is yes, then it goes to authorization, which is basically RBAC. Can I do what I'm trying to do for this particular object? And if the result is correct, if I can do that, it goes through a third phase, which is admission controllers. And admission controllers are embedded in the binary for the Kubernetes API server, and they allow for more fine-grained type of ruling. It's a little bit of rules, but they are hard-coded in the Kubernetes API server. So only the rules are there are going to be matching. There are two types of admission controllers, validate and mutate. Validate only says yes and no to this request. Mutate, they can also change the request if you want to. But there are two types of admission webhooks. There are, admission controllers that are special, which are validated admission webhook and mutate. And those two allow us to hook any code that we need inside those admission controllers. And that's where Gatekeeper puts the code. So basically, it's a webhook that's going to hook into those admission controllers. So once you create that API request, it's going to go through that policy engine. One of the great things, and one of the things that I loved when I started working with Gatekeeper, is that it's Kubernetes native. What does it mean? Is that it follows the pattern of extending the Kubernetes API with more objects through CRDs and then having a controller that does the reconciliation loop. Basically, what it does is that every time that we create something as a CRD that is Gatekeeper-like, the controller is going to do whatever it needs to do based on that. And we will see that in the demo. There are 4 different CRDs that get created when you deploy Gatekeeper in your cluster. But the 2 main ones are these 2, or the most important ones to understand what they do, are constraint templates and constraints. And constraint templates is where you define a generic rule with parameters. And then you can instantiate as many constraints, many different rules based on that single template. To put an example how this looks like, let's imagine we want to have a rule, and this is similar, this is more simple, but similar to the one that we are going to see on the demo. We want to create a rule that says, for a particular object, I'm going to require a set of labels. For example, for my pods, I want to have, I don't know, Gatekeeper label, let's imagine. Instead of just creating that rule that you can only use once, what you do is to create a template, and a template has the Rego code, a little bit more complex than the one that we saw in the example, but you get an idea. But it allows you to create parameters. And then once you have that template in your cluster, you can instantiate that as many times as possible, creating very different rules depending on how you instantiate that template. A couple of examples here. I have 2 different rules based on that same template, so I didn't have to copy the code over and over again. And this rule says all namespaces in my cluster require the Gatekeeper label. And a different one, the pods, only the default namespace require the do not delete label, for example. So we can see that just having one template, we can instantiate that over and over again, creating many, many rich rules. One of the great things that this opens is that Gatekeeper makes reuse of policy very easy. And probably the type of things as if you're already an OpenShift user or a Kubernetes user, you're already thinking about potential rules that you want to create in your cluster. The thing is that probably the same things that you have in your head, some other people have had already. So things like images can only come from approved registry, super important to avoid, for example, security issues. Deployments required to have a certain mandatory labels, for example. Container images must have a digest, so you make sure that you're shipping exactly the piece of code that you're intended to. Or things like containers must have memory and CPU limits and within a specified max value. Just to put 4 examples, but these are things that probably you already started thinking that you wanted to do for your cluster. So because of that, the Gatekeeper community, which is part of the OPA community, is part of the same project, have created this fantastic Gatekeeper library. And they have a lot of different constraint templates ready to use in your cluster for all the things that you think that you may need, at least to start with. And that's why I was saying that even though you may not know Rego to start with, you can start using Gatekeeper if you start using, for example, this library. And to put an example of what this library, once you enter in this library, what you're going to get. So you're going to get a couple of things. For every single rule, you're going to get the important thing, the thing that you have to apply to the cluster, which is the template. So in this case, for example, we have this rule that's making sure that all our ingresses are HTTPS only. So we only allow HTTPS hosts. So basically, every template comes with a description of what it does and some Rego code and some potential parameters. In this case, there are not, but some potential parameters in some of them. With this, it would be enough. You have the template. That's the thing that you want to apply to your cluster. But to make things even easier, what they've done is to, for every single template, they also add samples of use. So the first thing that they include is an example of an instantiation of that template. Remember that the template itself doesn't create any rules. It's not going to enforce anything on your cluster. You have to make an instance of that template. And this is what they're doing here. So they're on those examples, they create, okay, let's instantiate this one with the kinds that we want to make sure that we cover in this rule. They add that, but they also add an example of something that is going to fail that rule. So in this case, because that ingress that we are trying to create doesn't have HTTPS on the host, it's going to fail that rule. So just by using the library, you have templates ready to be used, ready to be applied. Obviously, it's good if you review the Rego code if you want to understand exactly what it's doing. But to start with is good enough to just believe it does. It's a great community. It's peer-reviewed, so they're all good. But it also gives you those examples to understand exactly how you need to be using those. Cool. So that library is here. So it's part of the Open Policy Agent. So go ahead and have a look. Let's see if there is already a rule for the things that you're already having in your head. If not, if there is something that this would be interesting and generic enough, feel free to try to contribute with a new template. That's what I did. When I started with learning Gatekeeper and learning Rego, there was a new rule that wasn't there. I decided to try to code it myself. And thanks to that, I learned how to write Rego. They were super easy to work with. They provided me a lot of feedback of how to improve my code. And now it's merged there. So it's a great way as well to try to learn Rego. Cool. The other thing that I love about this project, and again, I really like this project. I think it's run fantastically well, is that it comes with out-of-the-box observability, which for me, it's super important. As working as in Datadog, we believe that having good observability on your clusters is super important. So it comes with out-of-the-box metrics. So you will get things like the number of templates that you have in your cluster, the number of constraints, the latency and the number of requests to the webhook, the violations, the objects that are violating any rules in your cluster, et cetera, et cetera. So it comes with out-of-the-box metrics. So using that and a little bit more, we have created as well a Datadog integration. So if you're also a Datadog user, you will get this out-of-the-box dashboard with all that data and a little bit more, including logs, et cetera, that you can benefit as well. And we will see that in a second in a demo. So I'm going to start sharing my screen, and I'm going to do a little bit of a first demo. And once, then we are going to go back to the slides to explain a little bit more, and then we will do a second demo before we wrap up. So let me share my screen. So I have an OpenShift cluster. Hopefully you see my screen already. This is an OpenShift cluster. I'm using CRC, which is a project by Red Hat, which is fantastic to be able to have your local cluster in your system. So let's see what we have already in the cluster. So we have Datadog already up and running. So we already have Datadog set up, sending information about my cluster to Datadog. And now we are going to start adding Gatekeeper to it. So let's deploy Gatekeeper. And you can see once I start deploying Gatekeeper, a lot of things have been created. Not only the deployment, but also, as I said, the extensions to the Kubernetes API that we were mentioning. So the custom resource definition. So we have a bunch of them. We have config, we have constrained pod statuses, we have constraint templates, and constraint templates for statistics. So we have 4 of them. Remember that one of the ones that it was very important is the constraint template 1, which is going to allow us to start applying those templates too. Okay, so now that we have deployed and we see the CRDs, we also have started applying the controller. We were saying that Gatekeeper follows that pattern in OpenShift and Kubernetes, in which you extend with CRDs the API, and then you have this controller doing the reconciliation loop. So that's the controller manager here. This is the part that does that reconciliation loop. There is a second one, which is the audit one, that we will see in a second why is it for. One recommendation though, this is because it's just a demo. I just deployed one instance of the controller manager, but we recommend always to deploy the controller manager in HA. So at least 3 replicas to make sure that there is always one replica that is going to answer. The reason why is not super critical, but it's important. If the controller manager is down and you don't have no replicas replying to those webhooks, then everything is going to be allowed. So the default is to allow everything. Obviously, we don't want to block deployments to production if that happens, but remember, always deploy the controller manager as HA. Cool. So once we have that Gatekeeper up and running, if we check now, there is a special command for the Datadog agent, which is agent status. So what is going to happen is that the Datadog agent is going to notice that there is a Gatekeeper running in our cluster, and automatically is going to start gathering those metrics and sending them back to Datadog. So that's something that is done automatically in Datadog, thanks to something that we call auto discovery, which basically for all the integrations that we have, if you deploy something in your cluster that we have an integration for, we are going to start automatically enabling that integration and sending those that data back to Datadog. Cool. So let's try the first thing that we are going to try. And again, what I'm going to do is I'm going to use the Gatekeeper library. So the same thing that you would get cloning from that repo that I showed before. And you can see that there is a library and general. And we have, for example, require label. So we are going to try this one first. So as I said, the first thing that we will have is a template, a constraint template. Let's apply this one first, and now I'm going to show you how it looks like. So it has created that constraint template, required libraries. But actually, it has done 2 things. It has created that constraint template instance, but it has also created a new object. Wow, this is a lot too much. Let's grab this. It has created this new one, required library. So there is a new way to create those instances that we were talking about. Good. So how does the code looks like? So let me open here. So this is the template that we just applied. So it has a name, required labels, as I said, a description, so you know what this template is going to do. Requires all resources to contain a specified label with a value, regular expression, okay. It has the kind of object that it's going to create, the type of constraint that it's going to create, that we are going to create instance for. Set of properties, which are basically the different parameters that you can add. In this case, an array of strings. The labels are required, and the allowed expression that it's going, regular expression that it's going to accept, and some Rego code. Again, not important to understand all of it for now, but just to give you an idea, this is where the Rego code goes. Good. So going back here, so we were saying that aside from that, we also have samples. And we have here an example, all must have owner. But instead of just using the same example, let's see how we can start editing to tailor what we want to do in our cluster. So let's just copy this. And let's call it, for example, all must have OpenShift. So let's start editing that. So if we go here, this is our new example. And we have a constraint. So we have the required labels name, and we are going to change the name to OpenShift, for example. And the example here says for namespaces, but we are actually going to change to pods. Again, just showing you how, based on those examples, you can create your own rules very easily. And now I have to change the message that I'm going to give my users. You want to make sure that the message that you're giving back to your users makes them understand what went wrong and how to fix it, if they can fix it. So I can say all pods must have an OpenShift label. And instead of asking for a particular value, let's just ask for the key. We are fine if they just provide the key. So the next thing is that we need to change that key, and we can remove the value that we require because we are going to accept anything. Cool. Once we have edited it, we have to apply that. So let's move here. And let's apply the constraint. Okay, it was created. So let's go back here. So now that rule, once I have created that constraint in my cluster, it's working. It's like, as soon as you create that constraint, as soon as you create that instance of that template, from now on, you're going to need to apply that rule. So I have here an example of a very simple engine export. So let's clean this up a little bit. We have here a pod, simple engine export. It has a label already, run nginx, but that's not the one that we are requiring. So what happens if I try to create that object now that I have created that rule? It's going to fail. And this is a great thing. Now you can enforce the policy and create as many rules as you want in your cluster. The important thing is that it gives you the reason. So deny by the name of the rule or the rules, because you can fail several, that my pod was failing, and an explanation. All pods might have an OpenShift label. This is fantastic because now as a user, this is something I can fix. Obviously, you can create rules and say you cannot do that no matter what you do. That's not allowed. But in this case, it's just adding a label, so it's something that I can do. So if I go back here, or just here, if now I remember the value wasn't important, it was just the need of a key. So if now I add that key and I try to apply that again, now the pod has been created. So this is a super easy way to get started adding policy to your cluster, and it works out of the box. It works great. Good. But one thing that happened is that I have created a new rule that said all my pods have to have the OpenShift label. But actually, I'm running already a lot of pods. So if I, just to put an example, I have the pods, the Datadog pods. But if I put all namespaces, I have also all the kube system pods, etc., etc. I have already a lot of pods. So what happens with those? Because probably they don't have that. This was a new rule. They don't have that labeled yet. And this is where the audit pod comes into play. So when we were showing the Gatekeeper deployment, we saw that there is this audit. And this pod, what it's going to do is to check for prior violations to a new rule and basically describe you which ones are those. So if you go to the list of rules that you have in your cluster already, we have just one for now. This one all must have OpenShift. If I describe this object, it's going to give me all the list of the pods that are failing that one. So this is a great way because you make sure that you can create new rules that are new to your cluster, and you give enough time to your users to adapt to those new rules. Obviously, you will need to go in one rule by one rule. It would be very, very difficult because you will need to go one by one to see all the violations. And that's where one of the benefits of using something like Datadog for Gatekeeper. This is the dashboard. This is what we are running now. This is live with our cluster. So you can see that here we have, for example, the number of violations for that particular rule. In this case, we have 81 pods running in our cluster. We can see the logs to see when the audit happened, the problems that we have with that constraint. As I said, the number of requests to the webhook, the number of constraints, etc., and how our pods are looking. Cool. So that was the first demo. You can see that we already have that rule up and running. So let's go to the second one. So I'm going back to the slides. Good. So we saw a type of rule that it's very easy to make a decision based on itself. So all pods require a certain label. So the only thing that OPA needs to make a decision is the description of that object itself. So that's the only thing that it needs. It has the label. It doesn't have the label. Based on that, I make a decision. But you may want to do a different type of rule that says things like, the host in an ingress must be unique among all of the ingresses in my cluster. This is a rule that it's very important to make in your cluster to avoid clashes, to avoid people getting traffic for a different service that is not theirs, etc. So for this to happen, you need two things. You need the description of the ingress that you're trying to create, but also all the data about the ingresses that you already have running in your cluster. So this is where we get this other bit of, we said that OPA to make a decision, it uses two things. The Rego, the policy that is written in Rego, but also some data that it can store to make decisions as well. So this is a perfect example of something that we need to store for OPA to make a decision. How do you do that in Gatekeeper? You do that by creating another type of CRD that creates another type of object that is called config. Config.gatekeeper.sh, but basically config. And basically what it's going to say when I create that one is going to start gathering all the data that I put in here. So in this case, I'm saying, anytime that I create an ingress, doesn't matter if it's using the old API or the new one, every time that I create an ingress, it has to be stored in that data as JSON for OPA to use to make its decisions. So let's do a second. demo for this particular use case. My goal is to show you how useful is the Gatekeeper library to get us started. So let's go to library in general. Let's see what we have here. Unique Ingress host. This seems to be the one that we are looking for. So as any other of these templates in the library, it has a template. So let's have a look to that template first. So if we show this, we already seen this quite a bit of times. It has a name, it has a description, so you know what it's going to do. It's going to, the kind of object that it's going to create, and some Rego code. So let's apply. That's the first thing that we need to do. Apply that template. So again, the template itself doesn't enforce anything yet. You have to create instances of that template for it to become a rule in your cluster. But we saw something different from the one that we were seeing before. The example, we see this sync object. Let's have a look to that one as well. So you can see that this is the type of objects, the type of data that we need to store in a cluster for OPA to make the right decision for this particular template. This is a great thing as well for the Gatekeeper library. It doesn't only include the template itself or examples. If it requires to have data to make decisions, it's going to add that sync object, that config object already for you. So we have to apply that as well. So let's do that. Let's create that config object. Good. So if we go now to the examples, in this case, we are going to just use the example that is as it comes. We are not going to edit anything. Again, we have the constraint object, which is basically the instance of my template, in which the only thing that I need to do, because it doesn't have any parameters, is to tell it what objects in the Kubernetes API have this particular rule. In this case, any Ingress object. So let's apply that thing first. Good. So now that we have applied that constraint, that rule exists in our cluster from now on. So as I said, we had also examples of things that are going to fail. Let's have a look to one of them, because sometimes they add more than one example, just in case. So in this particular example, we see that we are trying to create two different objects, two different ingress. The first one, it has a host example, hostexample.com. And the second one that we're going to create is going to have the same exact host name. And again, the rule that we have is that in our cluster, in an OpenShift cluster, we only allow one ingress to have the same host to avoid clashes. So if we now apply that example disallowed, we can see two things. The first ingress was created correctly. Why? Because it was the first time that we had seen that particular host for an ingress. It was the first time, so there was no problem with the rule. It created the ingress. The second, but as soon as it was created, and this is, as you can see, it's fairly automatic. As soon as it was created, Gatekeeper knew that it had to grab that ingress and store it in a data format that OPA can understand. So the second one that we tried to create failed for Gatekeeper, and basically it gives us ingress host conflicts with an existing ingress, and it tells you which host is conflicting. So basically, that way you're able as well to create rules that are affected by the description of the object itself, but also the universe that is your cluster. Again, for that universe that is your cluster that OPA understands, you need to create these sync objects that we just saw. Good. So going back to the slides, So some recap before we wrap up. Gatekeeper enforces OPA rules on your OpenShift clusters. It's super easy to reuse policies thanks to that design pattern that they decided about constraint templates and constraints. The Gatekeeper library is a ready-to-use set of templates and samples, and we saw a couple of examples that includes not only the template, but also the sync object if it's needed, and the examples of things that would fail that particular rule. And finally, Datadog uses you to have full visibility of your OpenShift cluster, including Gatekeeper. So thanks very much. I hope it was useful. We have time for questions, so feel free to ask any questions on the Q&A. Happy to answer those.
Awesome. Well, we've gotten a couple questions in so far, but yes, as Ara said, there's plenty of time for questions. So if you do have one, please go ahead and use that question and answer tab, or you can actually just use the public chat and put your question in there, and we'll be happy to move it over for you. Okay, let's dive into the ones that we do have. Archer asks, is this code presented somewhere, such as GitLab, so that he could do it himself?
Yes, so can we see our slides?
Yep.
Are the slides already? Yep. So
the slides are still up, yeah.
So let me go back. Yeah, as I said, the Gatekeeper library is completely open source, and it's part of the OPA project. So if you go here to github.com/openpolicyagent/gatekeeper library, you can see all those examples ready to be used.
Excellent. Excellent. Okay. Next question. Is it possible to unit test OPA? And is it and to test it in a CI environment?
Yeah, the answer is yes. So you can run not Gatekeeper unit test. So if you want to unit test the code itself, the Rego, you would use the OPA library without Gatekeeper, which is a lot easier. And the good thing is that to get it started, it's also easy using the Gatekeeper library, because if you go to that same repo, you will see that any policy that goes to that repo, it's unit tested. So you can see that you will see a library folder, but you also see a source folder. And that source folder is where the source of the Rego is, and everything is unit tested. So you can see there how people are doing those tests there.
Very cool. All right, great. Let's see. Okay, so guys, hey, plenty of time for questions. If you have one, please go ahead and get it on in. We have one more question here, so hopefully we'll get a couple more in from the audience here. Our next question is the format of the Gatekeeper metrics Prometheus or Open Metrics? And if so, what are the benefits of using the Datadog integration? Are you still with us? You froze on us. I think we just lost Ara. Okay, I'll see if Ara comes back. If she doesn't, let's go ahead and do couple quick reminders. First of all, today's event has been recorded, so if you missed any or all of it, you will have the opportunity to access the webinar later on. We are going to be sending out an email after today's event that contains a link to access the webinar on demand. And you can always go check it out on devops.com as well. It's going to be living there. Just log on to devops.com/webinars and look in the on-demand section. It should be right there waiting for you. Okay, we're still waiting to see if Ara can rejoin us, and hopefully she'll be able to. But while we're waiting, oh, Ara, is that you?
Yes. Yes.
Hey, okay, all right. Glad you were able to rejoin us. Okay, the question was, is the format of the Gatekeeper metrics Prometheus or Open Metrics? And if so, what are the benefits of using the Datadog integration?
Yes, so it's indeed Prometheus Open Metrics, so you can still use it with Prometheus as any other. The benefits of using the Datadog integration is two things. First, you have that dashboard, that full visibility out of the box without having you to create those for you. But also we add metrics that are not in the out-of-the-box metrics by parsing some of the logs. So we parse the logs and we create new metrics that are not there.
Okay. All right, great. We've got a couple more questions in. Alok asks, the demo that was shown used the validating webhook for validating the resources against policies. Can you share a real-world example where mutating webhooks are used?
Yes, so Gatekeeper itself doesn't implement mutating webhooks yet. So they're planning to add that. So it's not there. So the only thing that you can do is validate your rule. But once they add that, if they add that, an example would be, for example, if you require HTTPS for your ingresses and it gets created with HTTP only, you can mutate that object and add the HTTPS automatically. So that would be an example of a way to use a mutating webhook. But for now, Gatekeeper doesn't implement mutating yet.
All right, great. I got another question here for you from Michael. He asks, isn't the Gatekeeper wrapper counterintuitive to the notion of having a consistent authorization policy framework across apps or components outside of the Kubernetes realm?
Very good question. So that's the decoupling thing. So the OPA is still the same thing no matter where you are, no matter if you're creating rules for your API web service or for Linkerd, or everything is OPA. That's the decoupling thing. So the thing that you're writing in Gatekeeper is OPA code. It uses the OPA library. It's nothing external. But then what it does is that because it's very difficult to create, you have to create a way to enforce everywhere that you are. OPA is the same, it's common, and then the enforcement is different. And the enforcement for OpenShift and Kubernetes, that would be Gatekeeper.
All right, great. Okay, so that is all the questions that we have. I'm going to leave the question and answer tab open to see if we get any last minute stragglers in. And once again, while we are waiting, just a reminder that today's event has been recorded. So if you missed the webinar, any part of the webinar, you'll have the ability to access it later on demand. And the webinar is also going to be on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars and look in the on-demand section. It should be right there. One more question just came in from Alec. Thank you very much for another one. What are the major advantages to using OPA or OPA over Kyverno?
Great question, but I haven't used Kyverno, so I wouldn't know what are the differences. What I know, so one of the benefits of using OPA, I wouldn't be able to compare because again, I haven't used Kyverno, but Open Policy Agent, it's becoming super popular in the cloud native environment. It's part of the CNCF, so it has a lot of community around it. Not sure about Kyverno, it may have as well, so cannot answer that question, sorry.
Okay, well, maybe we can get somebody from Datadog to follow up with you, Alec, and get your question answered. But for now, I'm going to go ahead and close out the question and answer period. And do want to thank everybody who did submit questions. And Michael, I know you just sent over a link. I'm going to go ahead and actually put that in the public chat so folks may be interested in taking a look at it. So this is an information about Kyverno there. So
yeah, thanks, yeah, Michael, for that comparison. Yeah. Thanks a lot.
Yeah. So just real quick before we close things out, I do again want to thank the audience for submitting such great questions. There were some really, really good ones. Before we close things out, I do want to do the drawing for the 4 $100 Amazon gift card winners. So without further ado, our first one today is, let's see, Michael F. Congratulations, Michael. Our second winner today is Amy H. Congratulations, Amy. Our third winner today is Derek L. Congratulations, Derek. And our fourth and final winner today is Edward H. Congratulations, Edward. We'll be following up with all 4 of you guys via your email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything there, please check your spam folder. Okay, great. So we looks like we are all set for today's webinar. Again, do want to thank Ara for a great presentation. I'm a big fan of the demos. I think it's pretty widely known that I love the demos. So thank you so much for having a couple demos in today's presentation. I enjoyed them. I know based on what the audience sent in as far as questions are concerned, they got a lot out of it as well. So thanks again, Ara. I really do appreciate it. I also,
thank you.
Yeah, you bet. I also want to thank the audience for joining me today. Great turnout and great event all the way around. So thanks again, everybody. And this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.